Society pictures a genius as someone possessing razor-sharp focus, unshakable confidence, and a perfectly organized daily life. The data shows something completely different. High IQ individuals statistically display cluttered workspaces, erratic sleep schedules, and persistent indecision. This chart shows the Dunning-Kruger effect, plotting self-confidence against actual competence. Notice the steep drop-off here. The sharpest minds systematically underestimate themselves. Isolating the gap between this low confidence curve and the high competence baseline reveals constant questioning acts as an active cognitive engine. Judging mental horsepower by a clean desk or a loud vase gets the math entirely backwards. It leaves us blind to the actual mechanics of a powerful brain. To understand those mechanics, we have to look past physical habits and examine how the brain organizes raw information. The first critical trait is divergent thinking, a cognitive process where the brain generates multiple creative solutions to a single problem. This animated network graph maps that process. Instead of following sequential logic, a divergent mind actively bypasses obvious, adjacent ideas to hunt for connections between wildly unrelated concepts. Compare that to convergent thinking, shown here as a simple, linear path. Convergent thinking relies on safe, predictable associations to arrive at a single correct answer. A cluttered physical environment actually feeds that divergent network. The chaos provides a higher volume of random data points, giving the brain more material to connect at high speeds. What looks like a lack of discipline to the average observer is actually a highly optimized environment for complex pattern recognition. Gathering massive amounts of chaotic data is only the first step. The real test is how a brain processes and defends that information. The average human brain naturally seeks out information that confirms its existing beliefs. It is a biological shortcut designed to conserve mental energy. But intellectual humility rejects that shortcut. It is the active, aggressive hunting of your own personal blind spots. By perpetually seeking out disconfirming evidence and tearing down their own arguments, highly intelligent people prevent their cognitive models from becoming rigid or obsolete. They treat their own worldviews as fragile hypotheses meant to be broken, rather than fortresses meant to be defended. Eventually, all this data processing has to result in a definitive answer. For most people, facing a complex problem with no clear, immediate solution causes acute psychological distress. This triggers a mechanism called cognitive closure. It is the overwhelming urge to finalize a decision rapidly, simply to eliminate the anxiety of the unknown. These two data gauges show the difference in processing. While the average mind seeks rapid closure, filling and permanently locking, the intelligent mind maintains a high tolerance for ambiguity, slowly expanding its capacity over long periods. There is a mechanical advantage to this delay. Sitting comfortably in that ambiguity allows the slow gauge to reach an extended capacity, capturing the absolute best answer instead of settling for the fastest one. Enduring the prolonged discomfort of not knowing is the exact mechanism that separates a brilliant conclusion from a rushed assumption. Looking at the evidence of these three habits forces us to reevaluate our core definition of intelligence. Intelligence functions as a dynamic, ongoing process that requires continuous maintenance to remain effective. Adopting these habits manually triggers the same feedback loops that produce high-level cognitive power in the first place. Practicing intellectual humility, leaning into divergent chaos, and delaying cognitive closure collectively build an advanced cognitive operating system. True intelligence thrives on the messy, uncertain habit of asking the best questions.